Hello again. We're adding and subtracting rational expressions, and this is a concept that is so painstakingly cumbersome, bothersome, tiresome for many students. And I mean, I can see why. It involves fractions and LCDs and polynomial expressions, and students tend to feel a little uncomfortable about doing this. So what I do is I usually do some sort of introductory, pardon me, until I do, before I add and subtract rational expressions. So that said, I go ahead and try this, and then we go step by step by step, and initially students' buy-in is very low, but you continue kind of going through it, and then it's not so bad. And the first thing I do is I say, okay, what's a half plus a half? But I don't phrase it like that. I say, what's half a Snicker bar plus half a Snicker bar? And they say, oh, it's a Snicker bar. I'm like, yes, but how do I get 1 from half plus a half? Because that seems a little confusing to me. And the answer is, well, somebody says, well, I mean, stop treating this like kids. I'm like, I'm not, well, first of all, you are kids, you're students, you're considerably younger than me. Number two, I'm not treating you like that. I'm trying to make sure that you're aware or you're cognizant of what's going on. I say, okay, well, here's what you do. You add up the numerators, and you leave the denominator alone when you're adding fractions with similar denominators. And then 2 divided by 2 is 1, bim. Okay, that's good. Yeah, that's exactly what you do. If you're adding or subtracting the fractions, if the denominators are the same, leave it the same, and only add or subtract the numerators. So that's 2 over 2 equals 1. So on the other side of the coin, half a Snicker bar subtracted by half a Snicker bar is no Snicker bars, and you get that by keeping the denominator the same, but subtracting the numerator. And 0 over 2, there's 0 pieces of food for 2 people. How much is each person going to get? Nothing. That's how it goes. But what we're going to do is we're going to do problems like this, except with variables as well. And we're going to do problems like this, which are just very annoying for students initially. But, keep a cool head and it's not so bad. I can't add a third plus a fourth. Now some people are going to say, isn't it 2/7? No. I even actually had a student one year, it was one of my first years of teaching actually, who said, that's what it is. And I said, no, it's not. And I would show with the, turning these into decimals, showing with pi graphs. The student didn't want to buy it. But I promise you, you can't add these together unless the denominators are the same. So with that said, I've got to figure out, how to get the denominators the same. And there's a couple different approaches here. Some people are going to say, well, I already know what it is. It's pretty easy. Turn these both into 12 and you're fine. Yeah, I agree. That's the answer. Let me show you a different way of doing it though. But we'll do that way first. So, okay, this one needs a 4. But what you do on the bottom of a fraction, you got to do on the top. This one needs a 3. What you do on the bottom, you do on the top. And that comes out to 4 twelfths plus 3 twelfths, which is 7 twelfths. Bam! That is the answer. Good job. Here's the other way to do it. And normally I would rather do it this way, but sometimes I think about it this other way. So I got a third plus a fourth. That's the same thing as this. It's 1 over 3. Now you might argue this is a terrible way to do it. And I don't disagree that it's not, but listen up for a second. If I reduce 4 into prime factorization, it's the same thing as 2 times 2. Now, what does this denominator have that this one doesn't? It doesn't have a 3. So I got to multiply by a 3. What I do on the bottom, I do on the top. What does this denominator not have that this one does? It's missing a 2 and another 2. 2 times 1 times 2 is 4. 2 times 3 times 2 is 12. Plus 1 times 3 is 3. 2 times 2 times 3 is 12. 7 twelfths. 2 different ways to do it. If your math skills are really good, you're probably going to end up just doing it this way. If they're not as good and you don't see the connection as easily, you're probably going to take more of an approach like this. Like, why would I ever do that? Because when you're working with variables and quantities, this way is actually a little bit better than this way. Not everybody just recognizes this off the top of their head. Now, if you do, great. It's going to be much easier. If you don't, you'll have to kind of chuck along through it. But that's our introduction. We're going to start adding and subtracting rational expressions. Till then, have a good day.